Hi, let's first learn a bit of theory of decision tree. So what exactly is decision tree? Well, decision tree is a supervised learning algorithm that can be used for both classification and regression. Oftentimes you use it for classification, but there are instances where you can actually use it for regression purpose as well. So here is a typical example of using decision tree for regression purpose. Now in decision tree, you actually divide your data into subsamples, okay, and there are various steps in coming up with these subsamples, and in every subsample, in to the smallest to the smallest of these divisions, you simply take average of the subsample and just assign. So how do we do that? So let's understand through an example, and that will be easier. So we're trying to predict the salary of employees, okay, and we have split the data into two categories in the first step. So categorized in terms of gender, so it's male and female. The second categorization or second split has been on based of whether the job is a tech job or a non-tech job, okay, so tech job or non-tech. So there are two splits, right? Two different steps of splitting the data, okay. Now somebody male and who is working in tech, we have got three observation in this particular subsample. We have got somebody having 50k, 60k and 70k. So the average of 50, 60 plus 70 by 3 is nothing but your 60, right? So average of salary in this particular node is 60. Similarly, somebody who is male and working in non-tech has average salary of 35. And similarly, somebody with female and working in tech has average salary of 70, right? 60, 70, 80, 70. Okay. And somebody with female and non-tech has an average salary of 45. Now, given this data, somebody who is male, tech, what is its salary? Okay. So, given this particular new data to you, you can simply use this tree and find out its salary. Okay, so he's male, so we'll straight away going there. We are at this step, and then he's also into tech, so we are here. So if we're here, the average salary automatically is considered to be 60. Okay, so for the entire subsample falling in that category, you will take the average salary. So average salary would be same for that particular subsample. So that's the way you use a decision tree for regression purpose. Now in classification, you were taking the majority vote, right? Majority vote in these subsample, but that's not the case here. It's the regression problem, so we just average it out. The question is, if this is done so easily, why do we need an algorithm? Why do we need to do it using a statistical software like R? Okay, there are many things actually, it's not that simple. Many times you will face problem with splitting your data into different subsamples. It's very clear over here that we have split it based on male and female, but we wouldn't be knowing how many splits will it have. It could have 3, 4 and many splits, right? Secondly, the problem arises when one of the variable that you have is continuous. For instance, if one of the variable given to use age of an employee, how do you take that into consideration or take that as one of the predictor of your salary for employees. So that is another problem. You cannot split a continuous variable that easily as you can split as you can use a categorical variable. All right, so for continuous variable, of course, you come up with this a threshold, and based on the threshold, you split your data. And to come up with that threshold, you will need some sort of an algorithm. Okay, and that's not easy to just manually go and do it by yourself. Rather, it will take a lot of time, so it's better to go with an automated algorithm, which you can find in many of these statisticals and machine learning softwares. Another problem that you will face is to giving priorities, like which one of these variables will be given higher priority. So why would gender come here? Why not take a non-take over here. Okay, so that could be one thing. Why gender over take and non-take, somebody's field of work? Why field of work, which is take or non-take, is getting lesser precedence over gender? Okay, so that's another thing to be decided in the algorithm also. All right. So last thing that is important is that how many of these variables or predictors will be used for predicting your data. So that's also important. Okay. So you can have as many number of these predictors predicting um, your target variable, but then it is going to grow big, and the purpose of having a very efficient model is going to go away, because you are having a much bigger model, which is very difficult to explain to someone. And remember, one of the greatest thing about decision tree is that it can well be explained very easily to even non-technical people. And if that is what we are losing out on this, then it is better to go for some other sophisticated algorithm instead of using decision tree, because it has to be kept very simple. So what we do instead of taking all the explanatory variables, is that we just use what is known as pruning of the tree. So we just make sure that we take only important variables or important explanatory variables in order to build the tree. Okay, and that can well be selected by using what is known as pruning of tree, where you cut the tree at one place and you don't go further. Okay, it decides. So using the pruning algorithm, you decide that what is the optimal way of using your explanatory variable in order to predict the target variable. So